All right, today we're using a soil pit to illustrate some of the soil properties that students have to judge when they're participating in the 4-H and FFA land judging competition. Now we know you are using or you judge a 2-inch core at the competition, but we wanted to bring a pit in to be able to better illustrate some of the properties I'm going to talk about here in just a second to give you, we tend to be visual learners, so we get a better idea of what we're seeing. Plus, we hope this will be used with our various teachers and those who work with students as an aid to help them to get them more comfortable with teaching these properties. So the four things I'm really going to accentuate or talk about here with the pit today are the amount of erosion, the depth of root zone, the aeration and drainage property, and the ability to supply moisture. So let's just start at the top, and again, we're going to look at the pit first. I'll come back and talk about the core here in a second. But if you notice right here, we got our tape. These are in inches, 4, 8, 12, 16 on down. We notice we've got some pegs in here illustrating some breaks in the soil profile. And this first peg you see somewhere between 4 and 8 inches. It's close to about a 7-inch depth there. And that indicates the amount of topsoil that we have in this particular profile. And the amount of topsoil, it's easy to differentiate. It's where you go from the darker to the lighter color, topsoil versus subsoil. And that thickness determines the amount of erosion that has taken place in the core that you're judging. And in this particular example, again, about 7 inches of topsoil. Now again, so this would be none to slight as far as the category that it would fall into, because we use a 7-inch topsoil depth, and if you lose 25% of that 7 inches, which translates to about 5 1/4 inches, then you would drop this from a none to slight to a moderate category if we only had 5 1/4 or less inches of topsoil. We also have the category of severe amount of erosion, and that's when we've lost 75% of this 7-inch topsoil plow layer. And that translates to 1 3/4 inches. So if we have 1 3/4 inches or less of topsoil, then we would be in a severe erosion category. So this shows this line is the demarcation between topsoil and subsoil. In this particular example, we have 7 inches, so we got none to slight would be our category on that. Now, if you're coming on down through the profile, let's talk about next the depth of root zone. And if you notice, we got 3 golf tees in here, and then we've drawn a line right through here. And you can pick this up real readily. We go from a brown, virtually model-free subsoil into this splotchy pattern of grays and browns and rust colors. And this is indicative of where we see the beginning of a Fragipan layer. And Fragipans are very, very common in a large portion of central Kentucky and west. It's on our general landscapes. It's not uncommon to have Fragipan layers, and these are root limiting layers in the profile. They are very dense. We actually had to pump this pit. This is the end of August, and we had to pump this pit before we could get in here and even talk about it, where water was perching on top. So it's not only restricted to water movement, the pan is also restricted to roots going vertically through it. And in judging the core, as far as where this comes up, it's where we see this gray color come in. We always use the gray color as the demarcation of where a Fragipan is usually starting to show up in the profile. And in this particular example, notice the line. Notice it dips right in here where we put our tape, but notice the red and white golf tees on either side of it. That's the top of the pan. So you see it varies anywhere from about, if I were bringing this on across, about 22 inches to right here at 28 inches. In this particular example, we would say that this would have a depth of root zone of being moderate because we fall out between 20 and 40 inches. It don't matter which peg we use here, it's somewhere between 20 and 40 inches where the top of the pan is. So we would say that this particular profile has a moderate rooting depth. Just to talk briefly, to show out you don't have this luxury because you're always judging a core, and I'll get to the core here in a minute. But one of the things that's very unique about Fragipans, we see these gray seams, the edge of these prisms that we see coming through the profile. And that's very classic. This is just a textbook example of a Fragipan soil. And let me say this. The gray, if we see the gray here in this particular profile, you don't have the luxury of knowing this, but we are on an upland site, okay? So as a rule of thumb, in much of western Kentucky, when you see gray in a core, and you're on an upland site, you got to be thinking about Fragipan as a rule of thumb. This does not apply to a bottomland site or bottomland floodplain situation. It strictly applies to upland positions. And generally, we're talking about upland sites where slopes are less than 12%. So we would be typically in an A, B, or C slope phase, as far as that goes. The next category on the score sheet that I want to talk about is aeration and drainage. And to determine aeration and drainage class, you're looking at one thing principally, and that's what is the depth to gray color? Where do you start seeing gray color show up in the profile? And if you, again, because we had a Fragipan, they sort of coincide in this case, but you can see the gray color showing up anywhere from about 22 to, again, 28 inches in this particular soil pit. So if you look at the guidelines on being able to pick drainage class, because we fall out with gray occurring somewhere between 20 and 30 inches, this soil would be considered to have be in a moderately well-drained class. In this particular case, again, this as far as aeration drainage class, and we fall between 20 and 30 inches, this is considered moderate. But if these gray colors occurred inside of 10 inches, in other words, from 0 to 10 inches, this soil would fit the poorly drained aeration drainage class. If these gray colors fell out somewhere between 10 and 20 inches, somewhere in this zone right in here, then it would fit the somewhat poorly drained aeration drainage class. And finally, or the last class, if the gray does not show up to below 30 inches, in other words, if it was somewhere 30 inches and below, or you don't even see the gray color, then the soil is said to be a well-drained soil profile. One other thing that we are able to illustrate with this pit and helping teach, now let's just assume that this Fragipan is not here. That's our root limiting layer in this case. But you also have another root limiting layer in here, and it occurs somewhere between 44 and 48 inches. And this, folks, is bedrock. And this solid bedrock, it's not just a few pebbles that you might see out there in a soil profile. This is Katie bar the door stuff. And this is this is definitely root limiting, but because in this case it's below 40 inches, it would still be said to this particular profile would be considered to have a deep rooting depth if we did not have a Fragipan and we went solely by the depth to bedrock. The fourth thing I want to talk about briefly, and this will be very general statement, is the ability to supply moisture. Now go back and realize, because we have a pan somewhere between 22 and 24 inches, this is not only limiting for water movement down, as I said earlier, but it's also limiting for root penetration as well. So this is, if you follow this line through here, that's our rooting depth in this profile. And because this Fragipan is occurring between 20 and 30 inches, the very best we could be on the ability to supply moisture would be moderate. There's no way we can be good because we simply do not have deep enough rooting depth for that to happen. Now, real quickly, let me sort of correlate what we're seeing. Again, we're teaching with the pit, but because you judge a 2-inch core, let's just look at the things we've covered already in the pit. We had about 7 inches of topsoil in the pit. If you look right here on the profile, then we've got about 7 inches of topsoil right there. That's about where the break is. Coming down to seeing where the top of the pan is, again, based on the depth of gray color, somewhere right in here between 22 and 24 inches is where the gray's showing up in the profile. So again, that's where our top of the pan is. It would serve as our depth that we'd use for rooting depth, which in this case would be moderate. It would also be what we would use, the gray coming in at that depth would also say that we were in the aeration drainage class of being moderately well drained. Again, even though the core is 40 plus inches, we have things that are limitations. In this case, this would be the Fragipan. And again, this is very, very common on upland ground in western and central Kentucky on gentle slopes of 0 to 12% slope.
So what I'm going to talk about real briefly, Jerry mentioned about the Fragipans being in western Kentucky and in central Kentucky, but once you go further east in Kentucky, we do get a slight little caveat to that rule that Jerry mentioned about seeing the gray on these upland positions. Typically when you get into D slopes or steeper and you start seeing these gray streaks like this, particularly on shale parent materials, then that can cause these gray streaks as well. And one way to identify whether it's a Fragipan or if it's gray shale is to take some of that gray material and texture it like you would your texture for subsoil or subsoil, and just ribbon it out and see if it's really, really sticky. This here is not all that sticky. It's just probably it's a medium textured soil. So this would fall into the realm of being a Fragipan, which Jerry mentioned. If it were really, really sticky, made a really long ribbon, and we were on a really steep slope where typically water wouldn't percolate down into the soil, chances are that's going to be a shale bedrock showing those features in there. So that's just what I want to talk real briefly about, that not all gray streaks equal Fragipan. So as you get further east in Kentucky, be mindful of that, especially when you're on very steep slopes, 12% or more on D or E slopes. So as I was saying, the gray streaks could possibly be shale. So if that is shale, then that would not be a limiting restriction until you get into hard shale bedrock. Just the gray streaks themselves is not a limiting layer if it's shale. Also, the aeration and drainage. That gray is not related to water at all. It's not formed from water. It's actually formed from bedrock parent material. So that would not affect the aeration and drainage. You would have to go down and look for, typically you probably would not have aeration and drainage issues when you're on slopes of D or E slopes. Typically those are well-drained soils, more than 40 inches to your wetness features. Okay, so here we have another soil pit we'd like to describe. We'll get a core later to show you what the core looks like, but as you can see, it's basically you got your topsoil and your subsoil. There's only two real main horizons here for describing for land judging. From an erosion perspective, you have about 12 inches of topsoil here, so that would obviously fall in the none to slight erosion category. Now, if you had a lot thinner topsoil, say for example, your topsoil ended right here around 4 inches, that would be considered moderately deep. Or if it was a really, really thin little layer, about 1 inch deep of topsoil, and that was it, then that would be your severe erosion. But as you can see here from the dark soil color of the topsoil, we have about 12 inches. So that's a none to slight. Now in the subsoil, you can see there's really no color change. It's pretty much brownish, reddish color from the 12 inches all the way down to the bottom of the pit. There's no mottling whatsoever. There's roots sticking out all over the place. It has tremendous amount of rooting depth. So being that there is no gray mottling whatsoever, this soil would be considered well drained. Again, we're looking for the grays to see where the drainage would be, and there is none. So here it's well drained. As far as soil depth, there is no root restricting layers whatsoever. We have roots, like I say, sticking out throughout, all the way up, down, all the way down here in 52 inches. We have roots sticking out still. So this is a deep rooting or deep soil with no root restrictions. Now that kind of equates to, on your ability to supply moisture, that this is a very deep, large area that holds water. So this is a good ability to supply moisture soil. The entire soil profile can hold moisture for plant availability. So this is a fantastic soil. Again, we're kind of on a B slope, so that would be a good ability to supply moisture.
All right, just to sort of correlate what Dave talked about with the pit with the 2-inch core, which is what you will be judging in your land judging competitions, I pulled a core probably 20 or 30 feet away from the pit. And in the big picture, you see we got a nice topsoil layer, and then we just have basically brown and reddish brown soil the rest of the way with no gray colors whatsoever in it. So in this case, Dave had 12 inches in the pit. This right here shows about 7 inches of a topsoil, so we're a little bit more eroded here, but still the class would still be none to slight because we're greater than 5 1/4 inches of topsoil. So we fit into that none to slight amount of erosion. And again, because we see the brownish colors, reddish brown all the way through, no grays whatsoever within 40-inch depth, or within 30-inch depth, then we have got a well-drained soil profile. This is what a textbook well-drained soil should look like with no grays. And again, couple the no grays, we're in an upland landscape position in western Kentucky with no grays, so we have no indication of the old dense root limiting Fragipan whatsoever. So this has a deep, as Dave mentioned in the pit, and the roots illustrate all the way, we're looking at roots all the way down to 5 feet in this profile. This has a depth of root zone of being deep here.
Okay.
One more thing we want to talk about just a little bit more on, and this is the practical side of our land judging competition. Our as a rule of thumb in row crop productivity in Kentucky, our yield limiting factor is moisture. It's available moisture. Moisture during the critical part of the growing season, and for us in Kentucky, that's usually in this late June to early August period of time when we're going through the reproductive R1 all the way through to R5 stage of productivity during the growing season. And in this well-drained profile with no root limiting layers, again, Dave pointed out, look how deep our roots are. We're seeing them all the way down here to nearly to 5 foot depth. So we have this whole capacity for storing water in between rainfall events for the roots to go to and find necessary for continuing out productivity, again, particularly during the reproductive phase of crop growth in Kentucky. If you remember back to our Fragipan pit, we had this Fragipan, or this dense root limiting layer, somewhere in here, somewhere around 2 foot depth. And that is the only part of the bathtub we have for storing water for the plant. And therefore we have significant restriction compared to this soil far as available water holding capacity. It cuts it in half even if you look at 24 versus 48 inches. So again, that's the practical side, because that is our biggest issue in Kentucky affecting productivity, is the ability to store water between significant precipitation events to be available for the plant, and that's particularly important in the R1 to R5 stage of crop growth.
Okay, real briefly, I'd like to talk a little bit about soil texturing. That's something we added to the contest in the past couple years, doing both the surface soil and the subsoil texture. And basically, texture is basically the amount of sand, silt, and clay sized particles in the soil, how the soil's made up. So the way we do that is by hand. You take a soil clod, moisten it up with your water bottle, and work it between your fingers until it gets a good consistency that you can easily squeeze it through your fingers and create what we call a ribbon that you squeeze out between your fingers. So here, with this texture here, with this soil, you can see I can make a fairly long ribbon. It just keeps going on and on, several inches long before it'll break off. This is what we consider a fine texture or a clayey soil. So that's something that's typically common in eastern Kentucky in the subsoils, sometimes in central Kentucky in the subsoils. You'll get into your limestone and your shale bedrocks will produce this kind of a clayey texture. Like I said, when you push it through your finger, keep the ribbon kind of thin, but not paper thin, but you can make a real long ribbon like that before it breaks off. So that is fine. The other one that we typically see in the surface is what we call a medium texture. which this one here happens to be the silt loam, which is very common all across Kentucky on the surfaces, since almost all of Kentucky was covered with silt-sized particles after the last glacial period. So here you can see it again. I'm doing the texturing, the ribboning out, but it breaks. It's not near as long as that last soil I had. So you just push it between your fingers, again keeping kind of a thin ribbon, but not too thin. And as you can see, it just breaks off in no time at all. You can't make a very long ribbon at all. So that's a medium texture. And then the third texture that we have, which is not common in Kentucky, but we do have it, particularly along major river systems and stuff, is a sandy texture. Again, you can squeeze it and it kind of lumps up, but there's absolutely no texture or no ribboning whatsoever to this. So I think most people are pretty familiar with sand. That's what the sandy texture is just basically your sands, where you can't ribbon at all, and you can make I don't know, you can squeeze it and make a cast or whatever of your hand, but that's about as far as it'll go. There's no ribboning whatsoever. But it will kind of hold together a little bit when it's moistened up. Otherwise, when it's dry, it's just, just sand. So those are our three textures here in Kentucky. With some practice, learning them with your fingers, doing the hand method on that, you should be able to get within those three classes on doing your textures for subsoil and topsoil. So what I have here is a slope finder that you find in the last page of the land judging manual here in Kentucky. They recommend for new people who've never done slopes before, to shoot slopes, who've never estimated slopes, to build one of these, to practice, to learn what your different slope classes are. And I basically made this in an evening with nothing more than this is a clipboard. I took the paper out of the back of the land judging manual. I did blow it up a little bit so it's easier for me to see, but you could probably use the original back page. And I just glued it to the board and put a push pin here with a string attached to it with a weight on the bottom. And then as you can see, it just dangles. And I had the rubber band on here to kind of capture the string when I'm shooting a slope. And then there's also two little pins here that I put in here for you to use as an eyesight to shoot from top of a stake to another top of a stake that are the same height off the ground. So you can use these pins, or if you want to do like what I did, I made the paper pretty much perfectly equal across the top of the board so I can use the top of the board to shoot my slope and not rely on these pins here. As long as everything's square, that should work. But like I said, you just line this up with, if you have stakes out there, make sure they're even height, and then shoot from top of stake to top of stake. And then you'll let your weight kind of dangle there on whatever the slope is. And I put this rubber band on here to kind of snap it in place. Then you can take it and read what the slope is. So that's something that you should practice on lots of different hillsides, on flat areas, and kind of get to learn what the different slopes is. So when you get ready for your land judging contest, you will not be able to use the measuring device in the contest, but that you will have practice learning, identifying what the slopes are just by walking up to the site then, because you'll be able to, you'll see enough variety from practicing.